Hello everyone and a very warm welcome to this video lecture series in which we are talking about neural networks and deep learning. So until in the previous video lecture, what we have learned is basically we have seen some very useful concepts about the neural networks programming and why these concepts were important to us because these concepts would be used by us in the further video lectures also when we would be given the concepts of neural network and we would be required to program the neural network. So those concepts would be required to us in the next few video lectures also. So from now onwards in this video lecture, what we are going to do is we are going to dive deep into the concepts of neural network. And from this video lecture onwards, the lectures would be very important and you need to watch each and every video lecture very sincerely so that your concepts are crystal clear uh, when you study. Okay. So now in this video lecture, what we are going to study is we are going to see about the neural networks. We are going to overview the neural networks of what we have studied till now in the neural networks. And further, we are going to see some of the basic notations and the some of the forward propagation and backward propagation steps that we need to perform on the neural networks. So let us continue over this lecture. So what you can see in this slide is firstly you can see this neural network. Okay, so this is a very simple neural networks with only one node. Okay, and the input to this node are x1, x2 and x3, and combining the input x1, x2 and x3, there is some computation that is being performed over in this node, and after this computation I am getting this output as y hat. Okay, so this is my final output of a very simple neural network. Okay, and what is the internal implementation or the logic behind this neural network is that suppose that I have x1 as an x, and suppose x2 and x3 basically represents my parameter that is w and b. Okay, so how can I get the output y with the help of x, w and b? So basically what I will do, I will need to transfer these parameters and variable into this equation or formula for finding the value of z. So what is the formula for finding the value of z? The formula is z equal to w transpose x plus b. Here W is a matrix of some dimension, X is a matrix of the same dimension as W, because these both matrix need to be multiplied or dot product has to be found between the two, and B is some real number. Okay, and ultimately after finding the value of Z, what we are going to do, we are going to apply the value of Z, whatever be the value of Z is going to be applied into the sigmoid function. Okay, and the value of this sigmoid function is stored in another variable, that is the a. Here a is also known as the predicted outcome. Okay, why predicted outcome? Because basically we are trying to predict the output given that we have some variable x and we have some test parameters w and b. Okay, and based on the result, how much accurate we have got our predicted outcome, we are going to basically tune our parameters w and b in this neural network. Okay, so suppose that if I find that my predicted outcome is quite having a very much difference between the actual outcome and the predicted outcome, so I'll basically tune my parameters, and if I find that after tuning the parameters my output is now much closer to the real output, then it will be a great success for me. Okay, so this is basically the logic behind implementing the neural networks. And what I do after that I would calculate the loss function. Okay, after that I would calculate the loss function, and ultimately this would give me the value of the difference between the predicted outcome and the actual outcome in the training set data. Okay, so this was the implementation of a very simple neural network, but this was up to the theoretical knowledge. Because what we need to do while implementing theoretically, we only lead a very simple neural network. Because if we take a very complex neural network, then it would be very tough for you to understand from that neural network. Okay, so we take some very simple neural networks, and using examples of these simple neural network, we implement it to the larger neural networks also. So this is basically the learning theory behind the neural network and deep learning. Also here you can see this neural network. Now, apart from this neural network that we have seen here, this neural network is more complex than this neural network. Okay, and what this neural network is doing, this neural network is basically comprised of 4 nodes. Okay, 1, 2, 3, and 4 nodes. And basically the complex neural networks are formed by stacking up the very simple neural networks. Okay, so the concept behind a complex neural network and a very simple neural network is all same. The only thing you need to do is you need to stack up the equations properly, so that these equations can be properly implemented to the large neural networks also. Okay, so what we have here is we have a comparatively complex neural network of what we have seen above. Okay, but in terms of practical implementation, when you see, then this neural network is nothing. Okay, we are going to see some neural networks that would be having thousands of lakhs and millions of nodes. Okay, so we are going to first take into consideration some very simple neural networks only. Okay, so let us move to the next slide. So as understood in the previous slide, we have this neural network, and we are going to understand some notations using this neural network. Okay, so what my notations would be, suppose that I consider this layer to be a single layer. Okay, this compilation of 3 nodes would be considered as layer 1, and this node is a single node. No other node can be seen below and above this node, so this can be considered as layer 2. Now this convention is the only convention that I'm using in this video lecture. There are some conventions that may change in the future video lectures also, but out of 100%, 80% of the conventions would be same as it is as I am teaching you in this video lecture. Okay, so this one is my layer 1, and this one is my layer 2. And finally we have our predicted outcome as y hat, and this is equal to a of 2. Okay, here a we also call it as the activation function. Okay, now what is there behind this neural network is that the inputs x1, x2, and x3 are firstly being applied to this node. Okay, and the output of these 3 nodes is being served as an input to this node, and finally this node is calculating the final output, that is the predicting the output y hat. Okay, and now suppose we want to write this neural network in the form of a computation graph, as we have seen in the previous slide. So how can we write this? Suppose that I have some variable x, and suppose that I have some input parameters as w1 and b1. Now what you need to consider is that here the notations are w1 and b1. Okay, so these notations basically belong to the layer 1, therefore w1 and b1 is written over here. And so with the help of w1, b1, and x, we can find the equation of z1 as z1 equals to w1x plus b1. Okay, this is the equation for z1. Okay, and applying z1 inside the sigmoid function, we get the value of a1. Okay, and now a1 would be served as an input to this equation where we find the value of z2. Okay, so instead of using a new x, we use the output from the previous equation. Okay, and this output would be served as an input to this equation, and we have the separate new parameters w1, w2, and b2, that is for the layer 2. Okay, w1 and w2 were the parameters for layer 1, w1 and b1, sorry, w1 and b1 were the parameters for layer 1, and W2 and B2 would be the parameters for layer 2. Okay, so these two parameters along with the output of the first equation, that is A1, would give us Z2 equal to W2 A1 plus B2. Okay, and this Z2 would be again applied to the sigmoid function here, and this would give us the final output, that is A2. Okay, so A2 is basically the predicted outcome, and that is what written over here. This predicted outcome y hat is basically the A2 that we are finding in this computation graph. Okay, so A2 equal to sigma times of sigma of Z2, and then after finding the value of A2 or y hat, we can apply this in the loss function as L of y hat comma y, or L of A2 comma y. Okay, so I hope this forward propagation step has been very much clear over to you in this video lecture. And now after performing the forward propagation step, what we do perform a backward propagation step. So let us take again the example that we have seen in the previous slide. And now if I want to apply some backward propagation step in this example, so what I will do, I need to find the derivatives or the gradients using the backward propagation. And so the derivative of A would be termed as dA, derivative of Z would be termed as dZ, and further we are going to find the very derivatives with respect to W and B, and those would be termed as dW and dB. And then after the finding the value of derivatives dw and db, what we are going to do, we are going to update our parameters, that is w colon equal to w minus alpha dw, and b colon equal to b minus alpha db. Okay, so this is basically the parameter update that we are going to perform, okay, after backward propagation. And now if we implement the same thing in this computation graph, so what I need to do, I need to find the value of d of a2, then I need to find the value of d of z2, and then I need to find the value of d of w2, d of b2, and d of a1, d of z1, and d of b1, d of w1. Okay, I need to find the value of all these derivatives or the gradients, and then after this I would be updating my parameters. Okay, so after finding the gradients I would be updating my parameters. So this is basically a very simple overview as what we are going to study in the next few video lectures. If you have not understood quite well as what has been taught in this video lecture, then you don't need to worry much about that, because these are the only concepts that we are going to break down, and we are going to elaborate these concepts, and we are going to see each and every implementation that I have taught in this video lecture in the next few video lectures. So you don't need to worry much about what has been taught, but some of you may have understood about what has been taught here. So I hope this video lecture would have been very much informative to you. If you really like this video lecture, then press the like button and hit the subscribe button, so that as soon as a new video lecture is uploaded, so it would be you would be informed in the form of a notification. And don't forget to share my video lectures to all your friends who are working in the field of neural networks and deep learning. Also, in the next video lecture, what we are going to see is we are going to see that how can we represent a neural network, because ultimately we need to have a simple and a standard representation for a standard notation for representing the neural network, so that in the future implementations it would not be a very confusion for us. Okay, so thank you very much.